Welcome to the deep dive. Today, let's maybe forget just adding years to life for a second.
Right.
We're diving into this February 2025 piece from lifespan.io. It's called The Underexplored Applications of Longevity Biotechnology.
Yeah, it's a really interesting angle.
Because, everyone talks about living longer, but this article suggests the real story, maybe, is how this science could change. Well, almost everything else, not just retirement.
Exactly. It shifts the focus.
So our mission today, let's try and uncover some of those surprising, maybe unexpected possibilities.
Definitely. Because the core idea, it isn't just about hitting 100 or 120. It's about understanding aging, the biology behind it.
Tinkering under the hood?
Yeah, precisely. And once you start tweaking those fundamental processes, DNA repair, getting rid of old cells, that kind of thing, you see these potential ripple effects. Applications pop up where you might not expect.
Okay, so where do we start? The article mentions veterinary medicine. That wasn't the first place my mind went.
It's maybe not obvious, but think about it. Our pets, they're living longer already, right? Better food, better care.
Sure, yeah. My cat's ancient.
But their healthy years don't always keep up. The thing is, biologically, the way a dog ages or a cat ages at the cellular level, it shares a lot of common ground with how we age.
Huh. So the same problems, basically.
In many ways, yes. Those senescent cells we talk about, mitochondrial decline, DNA damage, they get it too. So the therapies being developed for humans, they could potentially translate quite well.
So you can have, dogs staying puppy-like for longer. Maybe not puppy-like, but, healthier.
Healthier, more vital for much longer into their lifespan. And beyond just our companions at home, think about livestock.
Ah, okay. Agriculture.
Right. Healthier animals, maybe living longer, productive lives. That has real implications for farming, for sustainability, food production. It's not just about keeping Fluffy happy, though that's nice too.
No, I get it. Healthier livestock, maybe more efficient farming. Okay, so after pets and farm animals, the article shifts to cosmetics, which we do hear about, but maybe differently.
Yeah, it's a different angle. Traditionally, cosmetics, dermatology, it's been about tackling the symptoms of skin aging, right? Wrinkles, spots, sagging.
Surface stuff, covering it up, smoothing it out.
Exactly, damage control. But longevity biotech aims deeper. It's looking at the cellular reasons why those things happen.
So not just hiding the wrinkles, but stopping them from forming.
Right.
Or even reversing them at the source.
That's the goal, intervening at that fundamental biological level.
Yeah.
Preventing or, potentially reversing the actual aging processes in the skin cells. True rejuvenation, not just cosmetic trickery.
Making the cells themselves act younger.
Right.
Okay, that makes sense. But then it gets into stuff that feels a bit more sci-fi. Growing tissues, organs.
Well, yeah, it sounds like science fiction, but it follows logically if you think about aging as, this buildup of damage over time.
Right, cells getting worn out or damaged.
So if we can figure out how to generate healthy new cells and, crucially, how to organize them into working tissues, maybe even whole organs, that's a game changer.
For transplants, obviously. The waiting lists are huge.
Exactly. Addressing organ shortages is a major one, but also helping the body heal from, say, massive injuries, burns, trauma. Longevity research gives us insights into cell rejuvenation, which provides the building blocks, the know-how for this kind of regeneration.
Wow, okay, that's huge potential. Bioengineered organs, it almost sounds unreal, and the list keeps going. The article mentions industrial biotechnology. How does that connect?
It seems like a leap, doesn't it?
Yeah.
But it highlights how broad these principles are. We're learning how to maintain complex biological systems, keep them functional for longer.
Good.
So think about industrial processes that use biological components like enzymes in manufacturing, or yeast in brewing, or bioreactors growing pharmaceuticals.
Things that rely on living cells or molecules doing their job.
Precisely. If we can apply techniques, maybe derived from longevity research, to make those biological components last longer, stay more stable, work more efficiently.
You save money, resources, improve the process.
Exactly. It could lead to significant efficiencies. It shows that understanding how to preserve biological function has benefits far beyond just, human health.
That's a really cool connection I wouldn't have made. Okay, and the last one in this sort of scientifically grounded section, space exploration. Which makes sense when you think about it.
It's a major challenge for long trips. Like Mars.
Because space is hard on the body, right?
Yeah.
Radiation, 0J.
Incredibly hard. The space environment, especially the radiation, but also microgravity, seems to accelerate processes that look a lot like aging back here on Earth. Muscle wasting, bone density loss, DNA damage, immune system changes.
So longevity interventions could act like a shield. or a repair kit.
Kind of, yeah. Things that protect DNA, maybe clear out damaged cells more effectively, help maintain muscle and bone. These could be absolutely vital for keeping astronauts healthy enough to actually do the mission on, say, a 3-year round trip to Mars.
It really reframes the problem. It's not just engineering the ship. It's engineering the crew to survive the journey.
Okay.
So those are the more, let's say, near-term or plausible applications. But then the article shifts gears, right, into more speculative territory.
Yeah, it moves into looking further down the road, potential future impacts that are less certain, obviously, but follow logically from where the science could lead. And the first big one is cognitive enhancement.
Okay, so not just preventing dementia, but boosting brain power.
Well, that's the intriguing question, isn't it? If we can slow down or reverse aging processes in the brain, what does that mean? Preventing Alzheimer's and other neurodegenerative diseases is obviously a huge goal.
Absolutely massive.
But could it go further? Could we maintain or maybe even enhance things like memory, reasoning, learning capacity deep into what we currently consider old age? Keep that mental sharpness for decades longer.
Wow. Imagine scientists, artists, thinkers staying at their peak for 100, 150 years. The implications are staggering.
It changes everything. And that leads directly to the next point. How we'd have to rethink careers. Lifelong learning, too.
Because the old model wouldn't work, would it? School, one career, retire at 65.
It starts to look pretty inadequate if you expect to be healthy and capable for, say, 120 or 150 years. Retirement as we know it might completely change.
So multiple careers, people retraining multiple times.
Very possibly. You might have someone who's an engineer for 40 years, then maybe they become a historian, then maybe they start a nonprofit. Continuous learning wouldn't just be a good idea, it might be essential.
The whole life arc reimagined. That constant growth. It's fascinating, but it must ripple out into society, into families.
Oh, absolutely. The social and familial shifts could be profound. Think about family structures. What happens when you have 5, 6, maybe even more generations alive simultaneously?
Grandparents, great-grandparents, yeah.
How does that work?
How do relationships change? What about inheritance, social responsibilities between generations? And what about things like marriage, raising children, if till death do us part potentially means centuries?
Yeah, all those social norms built around a roughly 80-year lifespan. They'd all be up for grabs, wouldn't they?
Completely. It forces a reevaluation of almost everything we take for granted about life stages.
The article also brought up something really powerful: preserving knowledge. Culture.
Yes, the idea of intellectual continuity. Imagine people accumulating knowledge, wisdom, skills, direct experience over not just 70 or 80 years, but maybe 150, 200 years or more.
Like living libraries.
Exactly. Think of the potential loss of knowledge we currently experience every time a generation passes away. If people could contribute their expertise for much, much longer, it could accelerate progress incredibly.
Yeah.
Mentorship would be on a whole different level. The transmission of complex skills, cultural understanding.
It could be transformative for civilization, potentially. Less forgetting, more building upon accumulated wisdom.
Okay, and the final speculative area. This one's deep. Existential questions. Philosophy.
Right. If death isn't the relatively near-term certainty it is now, if we could genuinely expect significantly longer, healthier lives, it forces us to ask some fundamental questions.
Like, what's the point?
Well, yeah. What becomes our purpose? How do our ambitions change if we have potentially centuries to achieve them? Does our relationship with mortality itself shift? Do we become less driven or find new longer-term goals?
Does the value of a single day change if you have so many more of them? It's profound, both exciting and maybe a little daunting.
It absolutely raises those deep philosophical issues about what it means to be human, what drives us when the old biological limits are pushed back.
So it's crucial to remember, as the article points out, that this second category, the cognitive enhancement, the societal shifts, the existential stuff, this is speculative.
Very much so. These are potential futures. They depend on huge scientific leaps, first of all, and then on us as a society figuring out how to handle the consequences, the ethics, the practicalities. It's not a given.
Right. So stepping back, the big takeaway really is longevity biotech isn't just about living longer. That's almost the side effect.
It feels that way sometimes, doesn't it? The potential impact spreads out into, well, veterinary care, cosmetics, making new organs, industrial processes, space travel. And then maybe reshaping our careers, our families, our very understanding of a life well lived.
We've covered a lot, from the stuff happening in labs now, or plausible soon, to these much bigger, further out ideas.
Exactly. The core message is this field's potential is incredibly broad, far beyond just adding years.
And it underlines how important it is that as the science races ahead, we keep having these conversations about the ethics, the regulations, the societal changes needed.
Absolutely. Which kind of leads to a final thought, maybe for you listening. Considering everything we've touched on, the practical stuff, the far out stuff, which applications jump out at you?
Yeah, what seems most compelling or maybe even most concerning? And
Mm.
what shifts, what changes in how we think or organize ourselves, might we need to even begin to embrace that kind of future?
Definitely a lot to chew on as this whole field continues to evolve so rapidly.